Hello guys, I'm Ayswarya. Welcome back to Ayswarya's Math Classroom. In the previous video, we solved questions 1 to 4 from the end of chapter exercise of chapter 1, the use of coordinates. In this video, we'll continue with questions 5 to 8. As always, I will explain each question step by step in a simple and easy way to understand. So let's get started. Question number 5. What would a system of coordinates be like if we did not have negative numbers? Would the system allow us to locate all the points on a 2D plane? Imagine a coordinate plane without negative numbers. So if I draw a coordinate plane without negative number, see the coordinate plane here, this is the x-axis, this is the y-axis. On the x-axis towards the right, we have the positive number, okay? And top or above the origin, we have again positive numbers. So this is 1, 2, 3, 4, and up from the origin, again positive numbers. That is, here we could move right and up from the origin. That means only the first quadrant would exist. This is the first quadrant where we have the x coordinate and y coordinate positive. So if you look here in this Cartesian system, we have four quadrants. This is the first quadrant, this is the second quadrant, this the third quadrant, and this the fourth quadrant. So in the first quadrant we have positive, that is x and y both are positive. Second one, x is negative and y is positive. Third, both are negative. And fourth, x is positive and y is negative. So where both x and y is positive is the first quadrant. Any point on the left side or below the x-axis cannot be shown. So without negative numbers, we cannot locate any point on the 2D plane. That is why negative numbers are very important in coordinate geometry. So let us write the answer. If we did not have negative numbers, then we can only locate points having positive x and y coordinates in the first quadrant. So the second part of the question, would this system allow us to locate all the points on the 2D plane? So we can write no, such system would not allow us to locate all the points on 2D plane, as all points having negative coordinates cannot be shown. I hope you understood. Now let us move on to the next question. Question number 6. Are the points M minus 3 minus 4, A 0, comma 0 and G 6, comma 8 on the same straight line? Suggest a method to check this without plotting and joining the points. So here, how can we say if three points lie on the same line without drawing them? So here the points are M, A, and G. So how can we say that these points lie on a same straight line? And so here's the idea. If these points M, A, and G lie on the same straight line and A lies between M and G, then the distance from M to A, which is MA, plus from A to G, that is AG, is equal to or must equal the distance from MG. So if it satisfies this condition, all lie in the same plane or they are collinear. So what is the meaning of collinear or collinear points? If two or more points lie on a single straight line, they are called collinear points. I hope this part is clear. Then suggest a method to check this without plotting and joining the points. So let us start. We can use the distance formula for this. And now let us write the coordinates. That is M for M minus 3 minus 4, A 0, comma 0 and G is 6, comma 8. The distance formula is D is equal to root x2 minus x1 the whole square plus y2 minus y1 the whole square. So now let's find the three distances, that is MA, AG and MG using the distance formula. So MA is equal to, here M this is x1, y1 and for A this is x2, y2. When you're finding the distance of MA, it is equal to root of x2 is 0 minus x1 which is minus 3 this whole square plus y2 is 0 minus 4 the whole square is equal to minus a minus, this would become plus. So this is 3 square plus minus minus plus again 4 square in root is equal to root of 3 square is what? 9. 9 plus 4 square is 16 and this is equal to root 25. How can you write root 25? 5 into 5. Here it comes in pair. So we'll only take 1 5 from this. So this is 5 units. So MA is equal to 5 units. Now, next we have to find AG. AG is equal to, so here A in this one, this is x1, this is y1, then G, this is x2, y2. So we can write it as root x2 is 6 minus 0 the whole square plus y2 is 8 minus y1 is 0 this whole square, which is equal to 6 square plus 8 square, then root, that is 6 square is 36 plus 8 square is 64, which is equal to root 100. It is 10 into 10 and this is in pair, so we'll only take 110 out. So the answer is 10 units. So AG, we got the answer as 10 units. Next, we have to find MG. This is x1 and this is y1. So using the distance formula, we're going to substitute the values, that is x2 is 6 minus and x1 is minus 3, this whole square plus y2 which is 8 minus 4 and this whole square. Then 6 minus minus, it will become plus 6 plus 3 the whole square plus 8 plus 4 the whole square, which is equal to 9 square plus 12 square. Then root 9 square is 81 plus 12 square is 144. Here the answer is root 225. Root 225 is equal to root 15 into 15, which will take only 15 out. So here the answer is 15 units. Now we got the value for MA, which is 5 units, AG which is equal to 10 units and MG is equal to 15 units. Now let's check MA plus AG which is equal to 5 plus 10. This is equal to 15, which is equal to mg. Since the sum of the two smaller distance is equal to the largest distance, therefore points M, A and G lies on the same straight line. So what did we do in this question? We used the distance formula, and here would prove that this points MAG lies on the same straight line. I hope you understood. Now let us move on to the next question. Question number 7. Use your method from problem 6 to check if the points are minus 5 minus 1, B minus 2 minus 5 and C 4 minus 12 are on the same straight line. Now plot both sets of points and check your answer. So in our previous question we did the same method. There also we had to check whether the points were on the same straight line, and the method we used was distance formula. So the same method we are using here also. So here the points given are that is -5, -1, B -2, -5, and C 4, -12. So here these are the points, and we have to check whether these points, that means if R, B, C, if these 3 points are on the straight line. So here we have a condition like if RB plus BC is equal to RC, then we can say the points R, B, and C are on the same straight line. Okay. Now let us find the three distance, that is RB, BC, and RC using the distance formula. Is D is equal to root x2 minus x1 the whole square plus y2 minus y1 the whole square. RB, which is equal to, here this is x1, y1, this is x2, y2. So we are going to substitute the values. That is root of x2 is -2 minus -5 the whole square plus -5 minus -1 the whole square. So this is equal to root -2 plus 5 square. Here the minus minus will become plus, so that is why plus 5 plus -5 minus minus will become again plus the whole square. This is equal to 3 square plus -4 square equal to root 9 plus 16. This is equal to root 25, and this is equal to 5 units. So here RB we are getting as 5 units. Next we have to find BC. This is equal to, here in B this is x1 y1, and C this is x2 y2. So substituting these values in the distance formula, we'll get root x2 is what? 4. 4 minus x1 is -2 the whole square plus y2 is -12 minus -5 the whole square. This is equal to root 4 plus 2 the whole square plus -12 minus minus will become plus, this is plus 5 the whole square, and this is equal to root 6 square plus -7 square and equal to 36 plus -7 the whole square, which is equal to 49. So the answer is root 85 units. Next we have to find RC. RC equal to R, here this one is x1, y1, and C is x2, y2. So substituting the values in the distance formula, we'll get x2 here is 4 minus -5 the whole square plus y2 is -12 minus, and y1 is -1 the whole square, and this is equal to root 4 minus minus will become plus the whole square plus -2 plus 1 the whole square, and this is equal to 9 square plus -11 square equal to 81 plus 121, and the answer is root 202 units. So the values we are getting for RB is equal to 5 unit, BC is equal to root 85 unit, and RC is equal to root 202 units. So here this RB plus BC is equal to RC. So this is the condition that should be satisfied. Okay, so when you're substituting the value of RB, which is 5, 5 plus BC is root 85, which is clearly not equal to root 202. So if this is equal, we can say the points R, B, and C lie on the same straight line. But here this is not equal. So therefore we can write the points R, comma B and C do not lie on the same straight line. Now we have to plot this on the graph and show that they do not lie on the same straight line. Here you can see the graph. This horizontal line, which is the x-axis, and the vertical line, which is the y-axis. You all know that. So from this origin to the right side, all the positive numbers. And from this origin to the left side, we have negative numbers. I haven't written the numbers on the top because here in this graph, we don't need this first quadrant and second quadrant. So here we need the third and fourth quadrant for plotting the straight line, which here it's not a straight line, but to plot it on this, we need this two quadrants. So this line which is below the x-axis, I've written till -12. Okay. Now let us see the coordinates. The first one is r, which is -5, -1. So here on the x-axis we have -5, and on the y-axis here which is -1. So this is our point. So I'm going to mark the point over here. This is r -5 -1. Next is b -2 -5. -2 the on the x-axis over here, and our y -5, it is over here. So this is our point. And I'm going to write the coordinates, which is point is b -2 -5. Next c 4 comma -12. 4 here it is positive. So it is on the fourth quadrant. This is 4 and -12 over here. So this is the point we are getting. So you have to mark it over here. Okay. And we'll write the coordinates, which is C 4 -12. Now we have to join this point. See, after joining the points, you can see that here B do not lie on the same straight line. R is there on this line and C is also there in this line. If you join this line from R and connect it to B, then C won't be on this line. Okay. So anyway, one point will be missing. So this shows that these points do not lie on the same line. I hope you understood. Now let us move on to the next question. Eighth question. Using the origin as one vertex, plot the vertices of first part, a right angled isosceles triangle, and the second part is an isosceles triangle with one vertex in quadrant 3 and the other in quadrant 4. So let us do the first part. Okay, we have to plot this in a graph. And in the question itself, it is given that use the origin as one vertex. So here you can see this is a vertex, and isosceles means the two sides are equal. And here right angled isosceles triangle means one angle will be 90 degree. So I am taking the angle to 90 degree in the first quadrant. This is our first quadrant, second quadrant, third quadrant, and this is the fourth quadrant, right? So I'm taking 90 degree in the first quadrant, and see, you can take 90 degree in the second quadrant also, also in the third quadrant as well as in the fourth quadrant. But the only difference is that the figure will be different. It won't be same as mine because I'm taking in the first quadrant. Okay, if we are taking 5 on the x-axis, we should be taking 5 exactly on the y-axis because isosceles triangle means two sides are equal, right? So this 5 on the x-axis and 5 on the y-axis. Then after that, we have to join from here till here. Just to show you correctly, I am marking and now you can clearly see the triangle, right? Okay, I'm going to mark this as A and this B. The coordinates of A is 0 and 5 and B is 5, comma 0. Okay. So we can write it over here. That is angle AOB is equal to 90 degree. Then OA is equal to OB, which is equal to 5 units. Then we can say that AOB is an right angled isosceles triangle. I hope this is clear. These two sides are equal. This one and this one. We have 5 units in each these sides. That is from O to B and O to A. Then this is a right angle. So the angle we got 90 degree here. So this is an right angle isosceles triangle. Now let us do the second part of this question. An isosceles triangle with one vertex in quadrant 3 and the other in quadrant 4. So we already have taken one vertex as the origin here, right? And we have to take the other vertex in quadrant 3 and also in quadrant 4. So this is our first quadrant. This is our second quadrant, this one third quadrant, and this one fourth quadrant. So We have taken one vertex as the origin. Now I'm going to take the other coordinates in the third quadrant. X as -4 and y as -5. So here the point will be. Right, the points that is -4, -5. Let us name this as P. So when you're taking the coordinates here, it should be exactly same in the fourth quadrant. Even though the sign is different, it's okay. Here x we have positive, that is okay. So I'm going to mark it here, this point, which is 4 -5. And the point I'm going to name it as Q. Now let us join these points from origin to P here, then from P to Q and origin to Q. So in this triangle, OP and OQ, these two sides are equal. Then how can we say that these two sides are equal? This base and this perpendicular forms one triangle. And this base and this perpendicular forms another triangle. This is the perpendicular bisector. Okay. Here the 90 degrees forming. We have two triangles and these two triangles are congruent. Since they are congruent, these two sides are equal. So we can write OP is equal to OQ. So we are done with this question. Okay, one more thing. You can have a different figure also. If you're plotting over here, this is -3, -4, and then on the fourth quadrant it will be 3 and -4. See, you will be getting a triangle like this. See, a different triangle. When you took the different coordinates, now the triangle is like this. So you can take different coordinates and like that figure also, or the graph will also change. So this is how we get an isosceles triangle in quadrant 3 and quadrant 4. Now question 8 is finished and the remaining question I'll be doing a separate video. If you found this video helpful, please do like, share and subscribe. Thank you for watching.